1 year before the impact. With no city lights, all bright spots in the sky are stars. Some of them are planets reflecting the light coming from the sun, like Mars. But one of these dots is the asteroid. Later, it's going to be known as Chicxulub impactor. It got this name because of the region of modern-day Mexico where it fell. Anyway, at this point, the asteroid looks like a star. It has the same brightness as Neptune. You could even have photographed it with a high-quality camera. If only dinosaurs had thumbs. The impactor is now passing through Jupiter's orbit. From this distance, Earth looks like a pale blue dot. 1 month before impact. The asteroid has become much brighter. It's now the most brilliant spot in the night sky after the Moon. The asteroid crosses the orbit of Mars. Its tail, consisting of dust and gas, is getting longer and longer. It's now as long as 2 times the distance from Earth to the Moon. 1 week before the impact. The intruder's tail is now 5 times the distance from the Earth to the Moon, but the dinosaurs can't appreciate its beauty. To them, it's just another bright dot in the night sky. If this asteroid were flying toward Earth right now, scientists could pinpoint the exact location of its impact within a mile. Then we would evacuate people from the impact area and avoid a major catastrophe. 1 day before the impact. The Chicxulub impactor now holds first place among the brightest objects in the sky. The light surrounding it, called the halo, seems even bigger than the Moon itself. The asteroid is now passing through the Moon's orbit. It looks like a bright spot that leaves an ashy trail behind it. 1 hour before the impact. The light from the Chicxulub impactor is brighter than the full Moon, and its movement can be seen with the unaided eye. Nights on Earth aren't dark anymore. Only now, dinosaurs begin to feel anxious. All animals on Earth start to seek shelter. 10 minutes before the impact. The asteroid is now passing through Earth's orbit. Thousands of small fragments from its tail begin to fall on the planet. It looks like a meteor shower. So far, these fragments are too small. They all burn up in the atmosphere before reaching the surface of the planet. The asteroid is approaching South America. If someone was looking at it from Europe, it looked like a sunset. The bright dot of the Chicxulub impactor is falling behind the horizon. 2 minutes before the impact. Dinosaurs can now easily see the asteroid's shape. If they knew how to do it, they could even estimate its size. It's a bit more than 6 miles across, which means it's almost the size of Manhattan Island, and the giant's weight is 15 plus 15 zeros pounds. It's flying toward the Yucatan Peninsula at a mind-boggling 7.5 miles per second. At that speed, you could get from New York to Los Angeles in around 10 minutes, but you'd kind of burn up on the way. 10 seconds before the impact. The Chicxulub impactor is now approaching the ground. A few more feet and bam! The night sky suddenly turns white. The flash is so bright that the sun isn't visible at this point. The asteroid's entry causes a powerful blast that can be heard on the other side of the world. The huge asteroid begins to burn because of friction with the air. It heats up and splits into many pieces. These pieces shower on Earth. After a few seconds, the largest part of the meteorite hits the ground. Its mass and speed provide the Chicxulub impactor with an enormous amount of energy. In the next moment, a super powerful explosion shakes the ground. The blast wave from the meteorite begins to spread out from the impact site. It rips out huge chunks of soil and trees and then pushes them to the ground like dominoes. The temperature of the blast wave is so high that everything around the impact site catches fire. The energy released during the collision also penetrates deep into the planet. This causes the strongest earthquakes in our planet's history. They, in turn, generate tsunami waves as high as the Empire State Building. 5 minutes after the impact. The meteorite leaves behind a huge crater. It's as wide as Lake Huron and deep enough to fit inside 2.5 Mount Everests. Dinosaurs are running around in panic. They try to evacuate toward North America, but most of them don't make it through unfamiliar swampy territories. Another danger is the ongoing meteor shower. Hundreds of tons of ash and debris rise into the air. Heated up by high temperatures, they fall to Earth in the form of liquid lava. Ash and smoke fill the atmosphere and block the sun's rays. Earth plunges into darkness. For several more weeks, our planet will be totally dark. Acid rains will fall on its surface non-stop. There was a lot of sulfur in underground deposits on the Yucatan Peninsula. The energy of the explosion evaporated all this sulfur. Now it's cooling in the air, gathering in clouds, and dripping to the ground. Most animals survive the impact, but the mass extinction continues for many more months. The collision has plunged Earth into darkness, and this has wiped out most of the plants that fed on sunlight. The plant-eating dinosaurs have lost their main food source and begin to disappear. But plant-eating dinosaurs are the main diet of meat-eaters, and now dinosaurs like T-Rex have nothing to eat. Soon, they go extinct too. In other words, it wasn't a meteorite that wiped out dinosaurs, but hunger and climate change. Meteorites of this size fall once every 100 million years. It means that such an event might happen again. Will humans manage to survive this disaster? These days, we can look out far into space, and the appearance of an asteroid the size of the Chicxulub impactor won't be a surprise to astronomers. In general, asteroids that are more than 460 feet across are considered potentially dangerous. 70 billion tons of dust and ash from the collision filled the upper atmosphere. Moving at an astounding 10,000 miles per hour, this cloud spread from modern-day Mexico to cover the rest of the world, trapping an unrelenting heat beneath it. Static electricity charged up an electrical storm that caused fiery hail to rain down on the animals that didn't get wiped out at ground zero. As the temperatures continued to rise, wildfires, powerful enough to generate their own winds, blazed through once lush valleys and forests at 9 miles per hour, burning at 1800 degrees Fahrenheit. Just so you know, that's hot enough to melt solid aluminum. Smaller species living in the Western Hemisphere were able to survive the heat underground. But the big guys, like the Triceratops and T-Rex, were baked alive. 8,000 miles away in modern-day Mongolia, a dust superstorm suffocated any animals out in the open. That world-encompassing cloud we mentioned earlier kept temperatures too high to sustain plants for the few remaining herbivores to eat. A series of tsunamis with waves towering at 300 feet high ravaged nearly 13,000 miles of coast. Shockwaves from the massive earthquake continued for months, ripping tectonic plates apart like pieces of paper. Molten rock forced its way through the newly formed fractures in the earth, and dormant volcanoes were violently awoken with huge eruptions that expelled even more dust and debris into the deadly cloud already surrounding the globe. This cloud had now gotten to be a few miles thick, preventing the sun's rays from reaching the surface. What did surface, though, was a number of toxic gases, including hydrogen sulfide, which paralyzed the lungs and suffocated the few dinosaurs left at this point. Any remaining dinosaurs that managed to survive all of this starved to death, from the way their ecosystem had been so severely devastated. Because of that, they all had completely died out about 3 months after the asteroid collision. Contemporaries of the dinosaurs, like insects, early aquatic reptiles and birds, smaller mammals and fish, managed to survive by burrowing themselves in trees, deep underground, or underwater. Simpler organisms like mold and fungus thrived in the desolate landscape. The indestructible fern made a comeback once the sun's energy was able to penetrate the omnipresent dust cloud. Over thousands of years, these ferns grew into forests, which literally breathed new life into the planet. They produced oxygen and gave mammals the conditions to eat, breed, and evolve into the 10,000 species we see today. Now finally, the big question. Did you click the subscribe button already? Oh, wrong question. Here it is. What if all of that didn't happen? Let's explore our options. The asteroid could have continued on its path without getting sucked in by the Earth's gravitational pull, missing the planet completely, and letting the dinosaurs live out the rest of their natural lives in peace. Or it could have crashed into the ocean instead of on land. The water would have absorbed the energy of the impact much better, so the chain of events that followed wouldn't have been so devastating. No building-sized chunks of debris falling from the sky, no heat-trapping and sun-blocking dust cloud, and no volcanic eruptions. The tsunamis most likely would have been worse, flooding coasts and certainly racking up a high death toll, but they probably wouldn't have managed to wipe out entire species. It's unlikely that the resulting earthquake would have been an 11.1 magnitude, but it would have been powerful enough to do some major damage. These scenarios leave the possibility of the dinosaurs living and continuing to evolve. Had this happened, it would have been virtually impossible for any of the early mammals to survive long enough to build to the numbers we have today. Most of them in the Mesozoic area were just rodent-sized carnivores that hardly ever got to be the size of a cat. Despite being predators, they were still prey to larger carnivores. Not even their fast breeding would have been able to increase their populations quickly enough to make them a dominant class. Humans and related primates would, in all likelihood, not exist were it not for that ill-fated asteroid. Ooh, lucky for us. Not to mention, the animals that descended from dinosaurs, like crocodiles, lizards, snakes, turtles, and birds, would probably look much more like their ancestors than they do currently. In the purely hypothetical situation, where dinosaurs never went extinct, their brains would have continued to adapt and evolve along with their bodies. Most species of dinosaur had a relatively small brain-to-body ratio. And even though the larger dinos had proportionately large brains, they still couldn't complete any complex functions. Most paleontologists agree that the Troodon was the smartest dinosaur. It had a body about the size of a human's, a brain the size of an avocado pit, and an intelligence level on par with modern birds. It was already using visual and auditory signals in the late Cretaceous period. So just imagine what it would have become if it were given millions of years to develop. It might today have a job on Wall Street. Thinking ahead here, by 2050, we'll have flying cars, augmented reality eye lenses will replace phones, dinosaurs will come back, 3D printers will be able to print food. Wait a second, what? Dinosaurs? That's no joke. Your childhood dream of a real-life Jurassic Park could actually come true in 30 years. And yes, scientists were initially inspired by the famous movie. They wanted to find a mosquito stuck in amber and extract dinosaur DNA from it. The real thing about movies is that they tend to ignore the laws of reality. Real-world scientists came across a big problem. The oldest DNA sample they were able to get was only 1 million years old. Only because all the dinosaurs went extinct some 65 million years ago. That and DNA is an incredibly fragile thing. The chances that it remained intact since the Cretaceous period are slim to none. So instead of looking for dinosaur DNA hanging out in the belly of an ancient mosquito, they decided to take DNA from the closest descendants of these reptilian giants. No, it's not dinosaur-like reptiles, such as crocodiles and Komodo dragons. It's actually birds. Over millions of years of evolution, dinosaur hands turned into wings, and their predatory elongated jaws became beaks. Well, you don't need to be an expert geneticist or paleontologist to see some coincidences. Pelicans bear striking similarities to pterosaurs, and ostriches look kinda like velociraptors, only fluffier. So, which bird do you think they found to be the closest living relative to dinosaurs? Massive birds of prey like the Andean condor or the bald eagle? Maybe a hawk or falcon? Nope, the closest thing we have to dinosaurs today is the chicken. I know, this goofy farm bird doesn't look anything like a dinosaur. But hold your judgment and take a closer look at how it walks. Let's get rid of the feathers, cover it with scales, give it a toothy mouth instead of a beak, and stick a long, muscular tail on it. And voila! We have a mini Tyrannosaurus. Deep inside their DNA, chickens have the genes of formidable predators. Scientists want to genetically engineer that DNA to try and reverse evolution. If it goes right, they'll get a dinosaur hatching from the egg. The due date set for the goal by 2050. But will a world shared with dinosaurs be as cool as it sounds? Let's fast forward to 2060, into a hypothetical future where dinosaurs of all sizes have become commonplace. What will change? At first, the theme parks and zoos will reappear. Yes, the Jurassic Park universe will become reality. A new era, if you will. And it'll bring lots of money. Of course, modern technology won't allow the dinosaurs to escape. That's a mistake only the movies would make, right? After some time, you'll see dinosaur pet stores popping up, and people will be able to purchase their own little dino. True, they probably won't play fetch or learn smart tricks. Their brain won't be much different from a chicken's after all. Maybe they'll make cute accessories to go on your handbag. We'll also have dino sports. Jockeys will race on the backs of velociraptors. On second thought, those predators probably wouldn't let you saddle them so easy. Perhaps the fastest-running yet plant-eating hadrosaur can replace horses. People will find agricultural use for these massive reptiles. Imagine you live on a farm and you have your own huge diplodocus to help you plow the land. You'd also have plenty of fertilizer. We obviously couldn't let them live free in the wild. The large herbivores would eat all the plants, and there wouldn't be any left for other animals. As for the carnivores, what mammal could survive with a Tyrannosaurus, Spinosaurus, and Velociraptor in the food chain? The oceans would be a safe place for them to thrive. At least it's big enough to accommodate them. Dinosaur-like marine reptiles, such as plesiosaurs, nothosaurs, and mosasaurs, could live happily without humans interfering in their business too much. Though our species has a pretty insatiable appetite for seafood, so no promises. Now, how about this? What if the dinosaurs had never disappeared in the first place? Suppose that meteorite had fallen into the ocean or flown past our planet. The dinosaurs have been spared, but not for long. They'll eventually face a problem no beast has been able to overcome – humans. Our ancestors hunted giant mammoths, and they could probably handle the dinosaurs too. And that includes the mighty and feared T-Rex. The movies might show this monster outrunning a jeep, but in reality, it wasn't all that fast. Researchers analyzed their body mass and found that a Tyrannosaurus's bones wouldn't have been able to sustain a running speed of 30 miles an hour, an estimate scientists have been throwing out there for years. If the bones didn't break, the animal would have just fallen over. Plus, the dinosaur's legs were permanently bent, which wouldn't have let it run very fast. The final verdict? The terror-inducing predator could only run about 12 miles per hour max. Certainly not slow, but a human can compete with that. So, would they survive all these years until the modern day? Unlikely, especially for the gigantic ones. Diplodocus, Brachiosaurus, Triceratops, Stegosaurus, Brightsidosaurus? I made that last one up. Big animals need big meals, and there are only so many plants to sustain them all. But some might make it. I mean, there are present-day species of sea turtles that swam millions of years ago. Maybe small running dinosaurs would survive. They'd live in the streets like pigeons or in the sewers with the rats.
The T-Rex wasn't the largest dinosaur by far. The humongous Tyrannosaurus Rex that terrified us all in the classic dino flick, Jurassic Park, was not, in fact, even among the 15 largest dinosaurs. With a max length of 40 feet and a weight of about 10 tons, it was a pipsqueak compared to the biggest land dinosaur, the Argentinosaurus. This gargantuan, 100-foot-long herbivore made the ground shake with all its 75 tons of body weight. Basically, if you live on the 6th floor of a building, this dino could peek in on you through the window. Hey, tiny humans, what's for lunch? Still, to be fair to the T-Rex, I must say, it was the largest carnivore that ever existed. Well, I guess being the king of predators is better than not being king at all, right? While we're on the topic of size. Dinosaurs weren't the biggest animals ever, as much as we're used to thinking dinosaurs were the hugest things on Earth. Well, they weren't. In fact, the largest known animal in this planet's history is our contemporary. Meet the blue whale. At 98 feet long, it's about the size of the mighty Argentinosaurus, but its weight is far greater. You ready for it? A whopping 190 tons. That's about as heavy as your typical one-story house, by the way. Blue whales are real titans of this world, and there's never been anything bigger than them, neither in the sea nor on the land. I guess we can consider ourselves lucky to live alongside such amazing creatures. Dinosaurs aren't really extinct. Come again? Does that mean Nessie is real? I knew it! No, unfortunately for mystery enthusiasts, I'm not talking about giant lizards here. But you actually meet dinosaurs every single day without even realizing it. I know, sounds like complete hogwash, but it's true. According to scientists from the University of Berkeley, birds aren't just distant relatives of dinosaurs, but are dinosaurs themselves. You see, the classification of animals we're all used to, which divides them into families, species, and so on, doesn't take evolution into account. The system was actually created long before scientists realized that organisms evolved at all. So today, most biologists prefer to use another classification that incorporates animals' evolution over time, and that includes dinosaurs, which, get ready for it, evolved into modern-day birds. Hey, give me a like if you've ever fed some dinos at your local park. Dinosaurs were dressed in feathers, not scales. Since we were kids, all the books, cartoons, and movies show dinosaurs are reptilian creatures, looking more like lizards than anything else. Recent paleontological discoveries, though, prove otherwise, and not so recent ones too. Way back in 1923, explorer and adventurer Roy Chapman Andrews led an expedition to the Gobi Desert and found the first fossilized dinosaur eggs. Interestingly enough, those eggs were apparently laid by a strange bird-like creature that soon became a sort of star among the scientific community. As more fossils were discovered over time, paleontologists later concluded that most dinosaurs, including the T-Rex and its kin, had feathers attached to their bones. This fact was only overlooked for decades because nobody wanted to part with the image of giant scaly reptiles. Talk about the force of habit, huh? Jurassic Park just might become a thing one day. Evolutionary researchers across the world have been trying to understand the development of dinosaurs for years now. What they did was look at how chicken embryos grew inside their eggs. Remember I told you about birds being actual evolved dinosaurs? Yeah, that's the thing. And in 2016, a team of scientists from the University of Chile tweaked a couple of genes in some embryos to give them dinosaur legs, and they actually succeeded. The not yet hatched chicks grew with lower limbs resembling those of ancient lizards. Apart from purely scientific theory, show that birds could indeed one day be turned into real dinos. Of course, a park full of dinosaurs is still probably decades away, but the potential is there. I just hope scientists watch the movies before they make any decisions on the matter. The idea didn't work out too well, even in the fictional world. The biggest herbivores had equally large diets. As you know, some plant-eating dinos were really massive. In fact, growing as huge as possible was their way of protecting themselves from predators. Now let's imagine, say, a Diplodocus. How much food do you think it'd take to fill the belly of a 110-foot-long creature, weighing in at about 15 tons? Well, the short answer is a whole lot. Leaves and plants by the busload. In the era of dinosaurs, when it was warm and tropical almost everywhere, it was totally possible for these giants to find so much food, of course. But anyway, just picture such a creature walking into your yard and stripping every single tree of its leaves, and still being hungry after that. There are chicken-sized dinosaurs. When you hear the word dinosaur, you probably imagine a creature that's at least the size of a large dog. But the first thing that comes to mind is most likely a big triceratops or something. Well, dinos actually came in all shapes and sizes, and there were really tiny ones. The smallest known dinosaur to this day is called Compsognathus, and it was just about the size of a chicken. But scientists are even sure there were even smaller species. It's just that their bones haven't been found yet. Large fossils are obviously easier to discover, so it should come as no surprise that we mostly know about the bigger reptiles. Dinosaurs had fleas the size of roaches, and now I'm feeling itchy all of a sudden. Ugh. Dr. George Pointer Jr. from Oregon State University describes the prehistoric pests as not exactly fleas, because they couldn't jump as high as the modern-day ones. But still, a creature that was almost a full inch in length and could bite through thick dino skin does give you the heebie-jeebies. As Professor Pointer puts it, we can be thankful our modern fleas aren't nearly as big. I couldn't agree more.
Big herds of dinosaurs run through the forest. The temperature rises rapidly, and everything behind them begins to ignite. Some dinosaurs get stuck in swamps and can't get out. Pterodactyls fly over their heads as they try to avoid the blast wave that will soon cover the Earth. This event happened about 66 million years ago. It wiped out almost every living thing on Earth. Birds and flying dinosaurs were just about the only ones who could survive the most massive extinction event ever. Hey, don't blame me, I wasn't around then. Let's go down their evolutionary tree to look at the world's first bird, Archaeopteryx. It was about the size of a modern raven, but it looked like a small dinosaur with feathers. It had many small conical teeth, almost like alligators. It's because Archaeopteryx was closer to reptiles than to birds. However, its brain was 3 times larger than that of these reptiles. Although it had wings with feathers, it could hardly fly like modern birds. Its shoulder joints didn't allow it to lift its wings above its back, so it couldn't make a full wing beat. Most likely, Archaeopteryx was capable of gliding flights with small wing flaps. Evolution has led to more evolved species capable of full flight. Pterodactyls. These guys had no feathers, but membranes made of skin and muscle. Its wingspan was about the length of a human leg. It could fly perfectly and catch fish and small animals. Although flying dinosaurs could easily outrun terrestrial predators like velociraptors and T-Rexes, most of them didn't make it through the impact of a giant meteorite. Let's look at this event step by step to see how they got to our time. 10 minutes before the meteorite crash. A massive rock about the size of Manhattan Island is moving towards Earth in space. It weighs 460 trillion tons. That's like 3 trillion blue whales, the heaviest mammals that ever lived on Earth, and it's approaching our planet at 12 miles per second. At that speed, it could cross the Atlantic Ocean in just 4.5 minutes. That's twice as fast as our modern spacecraft could fly. 5 seconds before the meteorite crash. Ooh, this is getting tense. The Earth's gravitational force continues to pull the giant meteorite. It blows a hole in our atmosphere and creates a popping sound so loud you could hear it on the other side of our planet. All the animals on our planet wake up in a panic. They lift their heads up and see a huge rock that begins to burn through the air. Smaller fragments start to break away from the main meteorite. This fire is so bright that it shines almost like the sun. Flying dinosaurs and other ancestors of modern birds are the first to sense danger. They make a beeline to the sky and try to fly as far away from the impact site as possible to save their lives. The moment of impact. The colossal mass and velocity of the meteorite give it an enormous amount of energy. As soon as it touches the Earth, it causes an explosion of 150 trillion tons of TNT. The blast wave literally rips out chunks of our planet and throws them up. A huge wall of energy begins to move from the point of impact in all directions. It snatches the trees out with their roots and pushes them to the ground like dominoes. The shockwave completely wraps around our planet. This energy turns into heat. Everything around the impact site begins to ignite. Green jungles and trees turn into smoldering charcoal in seconds. The ground and rocks simply evaporate. The collision caused a massive earthquake. Some dinosaurs may have fallen into cracks that appeared in the ground. A strong earthquake caused a tsunami, with waves higher than the Empire State Building. Dinosaurs that weren't trapped in the burning forest were washed away by the enormous waves. The dinosaurs of North America tried to escape by running to the north, but the blast wave inevitably catches up with them. Flying dinosaurs have no problem with earthquakes or tsunamis. They fly high enough to avoid the giant waves, but they will have to contend with continuously falling meteorite debris. 5 minutes after the meteorite crash. A meteor shower of giant rock fragments continues to fall to Earth. Some meteorites were the size of a car, others were more like a large building. Ashes and dust rise into the air. Their temperature is so high that they melt and turn into liquid lava and then fall back to Earth, causing more fires. Meteor showers cause trouble for flying dinosaurs too. They have to maneuver and dodge the falling red-hot rocks. The high temperatures are a huge problem for them because it might make them lose feathers. With no feathers, they aren't able to fly. 10 hours after the meteorite crash. The dinosaurs continuously ran north all this time. They found themselves in unfamiliar territory with many swamps. Giant dinosaurs like T-Rexes have legs as long as an adult human's height. They have a chance to get through this terrain, but if they fell, they could never get back up. The smaller dinosaurs, like Triceratops, had short legs and couldn't grow through the dense swamps. 1 month after the meteorite crash. 15 trillion tons of ash were ejected into our atmosphere. A dark cloud blocked the sun, and the Earth was immersed in complete darkness. Surviving plants couldn't feed on the sun's energy and stopped producing oxygen. Surviving dinosaurs could hardly breathe because of the lack of air and a large amount of dust. The lack of sunshine in the sky made phytoplankton disappear. Many marine animals were left without their only source of food. The dust and ashes in the atmosphere prevent our planet from getting heat from the sun, and the temperature here is beginning to drop. The place where the meteorite fell was rich in sulfur. This toxic acid evaporated at the time of the impact and formed in clouds. Now there are acid rains on Earth. Flying dinosaurs now have to hide from these rains. They have to stay in caves and can't go outside to get some food. So far, a large number of terrestrial and flying dinosaurs have survived. They come out to see the aftermath of the disaster. The site of the impact was in present-day Mexico, the Yucatan Peninsula. The Chicxulub crater is located here. It's about 93 miles wide, like half of all of Lake Michigan, and it's 12 miles deep. You could plunge the whole Mount Everest in there, and there would still be 6.5 miles of available space.
This is it! You're about to be eaten by a vicious T-Rex. Any minute now. What you might not know is that you can literally outrun it. The T-Rex is a merciless hunter the size of a school bus, with a strong tail and blades for teeth. But it's actually quite slow, moving at a mere 12 miles per hour. It's as fast as the gray squirrel is. You're zigzagging through the forest. The terrifying creature seems to be still miles away. But then, it bursts through the jungle and is suddenly right behind you. Okay, now you can panic. The T-Rex may be a slowpoke, but its lungs are larger than yours. It means the critter could run plenty of marathons. Luckily, you reach a cave and hide inside, waiting for the dino to get bored. Oh wait, never mind. It's just broken through the rock and is back at it again. Will you make it out of this? We'll find out soon enough. A velociraptor can reach a speed of around 25 miles per hour, which means it's slightly faster than a brown bear. Putting these two head-to-head would be interesting. They're off! The velociraptor cuts through the air like a knife through butter, but the big fluff ball is galloping right behind the dino. This may be the only time we'd ever see such a race. Look, the bear is gaining on the competitor. Watch out, raptor. There are some bushes in front of them. The raptor just leaps over them and continues the race, while the bear barges straight through the bushes and stops for some yummy berries. When it's done, the raptor is long gone. Many of these dinos can be compared to modern-day chickens and ostriches in terms of speed and movement. An ostrich can reach a speed of around 45 miles per hour. That's similar to the speed of its ancient cousin, the ornithomimid. That creature even physically looked the same. Long legs? Check. A small head and a slender neck? Check. Anyway, they're running as fast as they can. The ostrich is speeding its way through the field and attempts to push the dino ostrich to the curb. But it misses and loses its step. The dino continues to run and makes it deep into the forest. Player 3 enters the game. The Compsognathus is a two-legged creature. It has the face of a regular lizard you can find in your garden, but the physique of an Olympic athlete, and plenty of razor-sharp teeth. This dino can reach a speed of 40 miles per hour, which is just on par with a greyhound. Even though it's not the biggest dino out there, it's still fearsome. This creature is merely looking for something to eat. But unfortunately, its dinner gets canceled. The ostrich and its dino cousin team up and outrun the lizard-like hunter. But it'll be back. Just wait for it. Back to Sarah. This armored beast can run at up to 20 miles per hour, which is just about the same speed as that of a brown bear. But let that poor animal have its berries. The modern-day rhino is the fastest among the mammals, weighing more than 2,200 pounds. The white rhino can reach a speed of almost 30 miles per hour. But Sarah will probably win this one. They're running side by side, with the rhino gaining momentum. Its body is more suited for running, but there are some obstacles in the way. At first, the rhino manages to break through a pile of logs and a fence, but after that, things are heating up. The rhino is slowing down. It can't break through all the barriers in its way. Meanwhile, Sarah is destroying everything in its path, as if it's on a walk in the park. And it's a good thing they're in the forest and not in the city, because the city is getting wrecked by a giant brachiosaurus. This powerful creature moves at a slow pace of 10 miles per hour, which is as fast as a pig moves. They're both at the starting line. On your mark, get set, go! And the dino wins. It was fast. The race is over. A fully grown brachiosaurus can reach 80 feet in length and grow as high as 40 feet. Just one step, and its long neck reaches the finish line. The Stegosaurus is known for having a set of plates on its back and tail, but it also has one of the smallest brains among dinos. Scientists claim that its brain is the size of a walnut. This slowpoke moves at a mere 7 miles per hour, a bit more slowly than a chicken, this modern-day dinosaur. The chicken is off to a good start. It manages to run past all the obstacles, and the Stegosaurus still hasn't figured out that it's taking part in a race. Now the chicken is just pecking the ground behind the finish line. Let's add something to make this race more interesting. There we go. The T-Rex is back and chasing the chicken and the Stegosaurus. This time, they're running for their lives. The T-Rex may be faster than them, but chasing a chicken is no easy feat. And good luck trying to take down a fully grown Stegi. They're running through the field, and the T-Rex is slowly but surely gaining on them. You're still hiding, watching the race. But suddenly, the T-Rex sees you and starts the chase. Round 2. You're running through the forest, trying to hide, but the big dino is catching up. Luckily, the Stegosaurus gets in the way and distracts the hunter. You make it out safely once again. The Dilophosaurus may be more of a bird than a lizard, but it's still quite scary. It's half the size of a T-Rex. It's best known for having 2 large crests running from its nostrils all the way to the back of its head. The black mamba is one of the most venomous snakes in Africa. It can grow up to 14 feet in length and slither at a speed of 13 to 20 miles per hour. Both creatures have almost the same speed, but one of them doesn't have arms or legs. They're both going as fast as they can, but it's hard to tell which one is winning. The dino can sprint fast, but the snake isn't that far behind. But in the end, it's the dino that takes the gold.
Boom! An explosion of supersonic waves, interplanetary heat, dust, fumes. The Earth's atmosphere has been invaded by a cosmic rock the size of Everest. A few seconds ago, this rock, weighing trillions of tons, was hurtling towards Earth. It could fly from New York to Anchorage faster than you could fry yourself an omelet. This monster's name? The Chicxulub Incident. Epic name, right? 66 million years ago, it crashed into the Earth. Back then, dinosaurs ruled the planet, but not for long. The epic collision took place in modern Mexico, in the Yucatan Peninsula, right near Cancun, where the dinosaurs were vacationing. Well, probably not. Still, the huge space rock hit the ocean, but even all that water couldn't stop the inevitable. The collision caused a huge amount of energy to be released. The horror on a planetary scale had begun. Imagine a mini-sun lighting up the surface of the Earth with tsunamis the height of the Statue of Liberty bursting from the epicenter of the watery impact. Not good. The blast blew through the surface of the Earth. It was as hot as an oven and burnt everything in its path. The impact provoked a colossal earthquake and serious volcanic activity. A bunch of volcanoes simultaneously released hot lava and ash into the prehistoric skies. Millions of tons of ash and soot poisoned the air. This formed a huge ash cloud in the atmosphere, which blocked out the sun's rays for several years. The long winter had begun. Only there wasn't any snow falling from the sky, but rain made of sulfuric acid. Yes, the Chicxulub incident might just be the most important thing that ever happened in the history of our planet. Even more than YouTube. Back then, there were loads of volcanic eruptions, a lot of flammable oxygen in the atmosphere, constant temperature changes. It was the perfect and worst time for all of this to go down. So, how are we so sure about all this? Well, the asteroid left an absolutely huge crater on the planet's surface. Today, this scar is hidden under the Gulf of Mexico. Scientists found a lot of places on Earth with abnormally high levels of iridium. This metal is very rare on Earth, but it's in a lot of asteroids that scientists have examined. Scientists studied some 66 million-year-old rocks. In the layers of rock, they found dust, the same dust that comes from asteroids. This could only have happened if a huge asteroid had crashed into Earth. The catastrophe led to the extinction of not only the dinosaurs, but also the asteroid. It was so hot at the point of impact, part of the asteroid just disappeared. A lot of water vapor and carbon dioxide shot up into the atmosphere. But the biggest problem, sulfur. It got kicked up by the asteroid impact and flew up into the air. These tiny sulfur particles blocked out a lot of the sun's rays. Without the sun, a lot of plants disappeared and the climate eventually got colder. The immense heat turned stones into glass. Scientists call these things tektites. The energy of the impact threw them up into the skies. After a short flight, the tektites fell down to Earth. But it wasn't pretty. Rain fell too, only instead of drops of water, you'd have seen hot glassy fireballs. They bombarded the planet's surface for days. The tektites set fire to everything. Scientists found evidence of this all over the world, not just near the collision site. But a lot of things from back then are still a mystery. Some scientists think that Chicxulub wasn't even an asteroid. It might have been a comet. Asteroids are mostly made of stone and metal. Most often they kind of look like a potato. A comet contains rock, metal, and ice. Comets look like dirty cosmic snowflakes, complete with ammonia, methane, and carbon dioxide. Comets sometimes come from the Oort cloud. It's a huge cloud of ice and debris around our solar system. From time to time, comets break free from the pack and head towards our sun. According to scientists, this special comet flew right past Jupiter. The gravity of that huge planet accelerated the comet even more. It flew towards the sun, gaining more and more speed. The comet's outer ice shield started to evaporate, and it probably gave off a lot of dust and gas, which made it look like it had a tail. The sun's gravity eventually shattered the comet apart. One of the fragments flew through space and crashed into the Earth 66 million years ago. So, asteroid or comet? The truth is, we'll never know. What we do know is that the Earth was seriously unlucky to be in its path, and it was never the same again. The catastrophe stopped the development of 75% of life on Earth. Some bigger marine animals, like crocodiles, turtles, and fish, survived the impact. Out of all land animals, the only ones to survive were the ones that were, on average, smaller than the modern raccoon. That includes a bunch of special species of dinosaurs, the ancient ancestors of birds. Scientists believe they survived for two reasons. After the huge impact, it took a long time for plants to start growing again, and a lot of animals didn't survive. Most remaining animals didn't have enough food. But these dinosaurs had a beak. With its help, they could split open nuts and dig seeds out of the soil, so they survived. The second reason is that these lucky guys had bigger brains. Some people think that they were able to cooperate with each other and quickly adapt to the new conditions. 66 million years ago, I wasn't around then, a huge asteroid hit the Earth and triggered the mass extinction of almost all living creatures on the planet, including dinosaurs. Had the space object crashed somewhere else, some dinosaurs would have been able to survive and still live nowadays. According to some research, the asteroid had about 1 in 10 chances of wiping out the dinosaurs and other animals of that time. It was way more likely to just hit the ground without any strong destructive consequences. To understand how things could have turned out if the place of the collision had occurred elsewhere, we need to find out what happened that day and why the disaster turned out to be so devastating. This huge space rock fell into the coastal area of the Yucatan Peninsula in Mexico. This caused a chain reaction that triggered natural disasters around the world. The place the asteroid hit is called Chicxulub crater. Now half of this area is underwater. The asteroid was about 7.5 miles in diameter and moving at a speed of 27,000 miles per hour. This rock, bigger than Everest, was rushing toward Earth faster than the speed of sound by almost 40 times. Wow. The energy released in the collision was as powerful as an explosion of about 10 billion atomic bombs, and the destructive force of the blast wave was just one of several disasters. The asteroid happened to fall in one of the worst possible places, and because of the way it fell, it threw a huge amount of dust into the air. Imagine you're jumping into the water like a professional athlete vertically, leaving hardly any splashes behind. And now think of how much water splashes when you jump into the pool like a cannonball. So the asteroid landed the cannonball way. The second disaster the asteroid provoked was soot burning. A small part of the Earth's surface consists of rocks. Only a tiny percentage of that part was rich in oil and sulfur back then. The asteroid burned and lifted so much soot into the air that it would be enough to fill an indoor baseball stadium. According to research, 65 million years ago, only 13% of the surface of the entire planet could have contained the necessary amount of organic material for the formation of such a volume of soot. That's why this place was considered the worst. If the catastrophe had happened on the territory of the other 87%, then dinosaurs would have been alive today. A huge cloud of soot and carbon dioxide rose into the air and covered the sun. The soot turned the sky gray and partially blocked sunlight. This led to a quick drop in temperatures almost all over the planet. It seemed like Earth was inside a gray veil. Many plants and animals couldn't survive the cold snap. Trees began to wither because of the lack of sun. The photosynthesis process was disrupted. The cold and withering of trees led to another catastrophe: global famine. Herbivores couldn't survive because they lost almost all of their food. Plants, flowers, and trees didn't manage to get through the catastrophe. These destructions spread far beyond the asteroid impact site. Hot dust particles, asteroid chunks, and small pieces of rocks settled to the ground across the continent and caused large-scale forest fires. Burning trees threw even more soot into the air, which made the situation even worse. The huge asteroid brought heavy metals with an increased level of toxicity from space. The melting of these substances during the collision provoked firestorms. The asteroid didn't only hit continental land but also water, which triggered a huge tsunami. But that's not the worst part. The seabed was filled with sulfate, and when the energy of the asteroid burned it, it provoked the release of sulfuric acid into the atmosphere. The acid cloud mixed with a cloud of soot and began to spread throughout the sky. Hot rock particles were falling to the ground like fire rain. An acid rain started because of sulfur. It lasted for almost several days and left no chance for the animals to survive. Acid rain made the water in rivers, lakes, and seas poison. The acid destroyed anything that couldn't burn. A part of the clouds went to wreck the land, and the other part the ocean. This made the situation even worse, as sulfur droplets wiped out a huge amount of seaweed and phytoplankton. The ocean generates almost half of all oxygen reserves on our planet. Those days, the sea creatures living in its upper parts were destroyed. It wasn't the blast wave, but lack of sun, acid, darkness, and cold that became the main reasons for the extinction of dinosaurs. But even when some lizards escaped from fires and sulfur, they met the sea element. The asteroid impact caused large-scale tsunamis across the planet. The very first wave was around 1 mile in height. That's almost 3 times higher than the Empire State Building. Billions of gallons of water were moving at 90 miles per hour. A wave this strong could easily destroy half of New York today. The meteorite created a series of waves 52 feet high. Massive walls of water the size of 5-story buildings collapsed on the shore and demolished everything in their path. Lack of sunlight, temperature drop, acid and fire rains, reduced oxygen production, forest fires, giant tsunamis, and the explosive wave with the power of 1 billion atomic bombs. All this reduced the biological diversity of Earth by 75%. Yeah, that'll change your climate for sure. Giant asteroids used to hit Earth before, but they never caused such disasters all over the planet. What if this asteroid had fallen into another place, say a forest, far from water and mountainous terrain? This would have caused severe fires. A huge black cloud of ash would have risen into the sky and obscured the sun. But it would have unlikely generated acid or fire rains. Most of the species of the planet could have survived this catastrophe. Ladies and gentlemen, welcome to the fight of the century. In the left corner is the most famous dinosaur of all time, Tyrannosaurus Rex. Let's call her Tyriana. She existed about 70 million years ago and was a true queen in today's North American territory. No one could defeat her in a fair battle. Well, except for that big meteor. Spoiler! In the right corner is the nightmare of the sea, Megalodon. This one's named Megan. This species went extinct about 3 million years ago, but legends about it are still alive. It's the biggest shark that ever existed, and it was a super predator in its time. Both fighters are the highest predators in their category. But what happens when they meet face to face? To find out, let's move on to the first category, size. The largest T-Rex ever found was named Scotty. Hey, beam me up! His hips were about 12 feet tall. But if Scotty straightened his back, he would be about 42 feet tall. It's like putting 3 giraffes on top of each other. And if you wanted to pet this cute guy on the nose, you'd have to stand on the shoulders of 7 people to reach him. Even though our T-Rex is not the biggest of its kind, Tyriana still remains one of the most dangerous. But now, let's look at the size of her opponent. The size of the Megalodon is still a controversial thing. The fact is that the only remains of this ancient shark are teeth and vertebrae. So scientists can only guess about the real size of this shark. But even by the most modest calculations, it's bigger than T-Rex. Megalodon was about 50 feet long, which is more than a school bus. It was not only the most massive shark that ever existed, but also the largest fish in the world. Its closest competitor in size was a modern whale shark, but he loses to Megalodon by as much as 10 feet. So, in the size category, Megalodon left no chance for T-Rex. The first point goes to the giant shark Megan. The next class is weight. Let's start with Megan. Usually, adults had a weight of 27 to 59 tons. This is like 3 heavy-lift transport helicopters, or almost like a tank. Actually, some houses have less weight than Megalodon. Its only competitor in the sea is the blue whale. What does T-Rex answer to this? Although it's an incredibly large predator, the largest individual rexes could only reach a weight of 14 tons. That's relatively small for its size. T-Rex could be terribly slow and clumsy, but some of its bones are hollow. This is what reduces its total weight. Thanks to this, she could be much faster and more agile without losing strength. But we see that Tyriana loses to Megan in weight by at least 3 times. So, another point goes to Megalodon. Next up is speed and agility. According to different estimates, Tyrannosaurus rex could run at speeds of 11 to 45 miles per hour. For comparison, the speed of the fastest human on Earth is only 16 miles per hour. So, you do the math. Yep, we wouldn't have had a chance to escape being lunch for T-Rex. But what about maneuverability? Tyriana seems to be big and clumsy. However, T-Rex had excellent balance because of her massive tail and could turn and change direction very quickly. And look at her legs. She clearly doesn't miss a leg day. Now let's look at the second fighter, Megan. Scientists have found that the Megalodon could swim at a speed of about 11 miles per hour. This was enough to become an ultimate predator, but it was inferior to many other species. For example, the fastest sea creature is the sailfish. It can reach 68 miles per hour, about 100 feet per second. Besides, because of its heavy weight, it could not quickly turn or maneuver. Imagine a giant truck needing to make a U-turn. So, when she attacked, she had only one chance to strike. If she missed, she went for a second lap. This gave her prey enough time to run away. In this round, T-Rex finally gets her first score. But we're still 2-1 in favor of Megan the Megalodon. Okay, moving on to the next category, fighting skills. Megalodon was definitely the best predator in the aquatic world. Not only because of its size and mass, but also because of its intelligence. Scientists have found traces of Megalodon's teeth on the remains of whales. They concluded that Megan aimed at her prey's weakest spots and knew where the vital organs were located. Other remains of Megalodon's victims had many bone fractures. This suggests that she was not shy about using her weight as a ram. Such a 50-ton ram could easily break through concrete walls. Some individuals prefer to attack the whale's tails and fins first to immobilize them, then attack a defenseless victim. This makes the Megalodon an excellent strategist. Megalodon's prey just didn't have a chance. So, this shark had 2 main techniques: ram and ultimate bite. But the arsenal of T-Rex is much broader. Like a Megalodon, it had the strongest bite of its kind and also used a ram. Although its weight was not as big as Meg's, Tyriana could reach a much higher speed, and her impact was much more powerful than that of a shark. On top of that, she could strike with her tail, and her legs had a tremendous force and could hold the victim. No doubt the T-Rex arsenal is much more diverse. So this point goes to the dinosaur. Now it's time for the bonus category, the prize of audience sympathies. T-Rex is undoubtedly the most famous dinosaur of all time. It's appeared in movies, TV series, cartoons, video games, and even postage stamps and memes. And its skeleton in the American Museum of Natural History is the most recognizable in the world. But there are also many myths about it. For example, the idea that it could only see moving objects. In a famous movie, the heroes escape from a T-Rex by just remaining frozen in place. Well, first of all, a dinosaur could easily smell them. Secondly, T-Rex had an excellent vision. It was actually 13 times clearer than humans. Megalodon, on the other hand, has the reputation of a real devil. A scene where Megalodon destroys a fishing boat is still a cult favorite and frightening for viewers worldwide. But because there were so few remains left of it, we can only guess what it really looked like. So, Instagram T-Rex would be much more popular. T-Rex takes this point. Let's move forward. The score is 2-2. So the results of the battle will be decided by the last round. Combat tools. Tyrannosaurus rex had the most powerful bite force of its kind. It could easily break dinosaur bones much bigger than themselves. But the power of their bite was limited by their teeth. They had a weak layer of enamel and were quite brittle, though they rebuild quite quickly. Her front hands have sharp claws, but this weapon is mostly useless because of the structure of these arms. Megalodon has only one dangerous tool, its teeth. But they can be worth everything that T-Rex has. The teeth of the Megalodon were triangular in shape and were over 7 inches long. These are the most massive teeth that have ever existed, and it had 250 teeth, arranged in 5 rows. Each of them was incredibly sharp and could penetrate through the thick skin of whales. Also, the Megalodon's jaw was 6.5 feet wide. An adult person could easily fit in there, but not for long, because Megalodon had one of the strongest bites on our planet. The gong sounds, and it means it's time to start the fight. These two predators meet on the coast of North America. Megalodons mostly lived in deep waters, but sometimes they hunted near beaches. T-Rex was also in this area, and now these two predators have come face to face. In shallow water, the Megalodon becomes even slower, and T-Rex easily evades its bite. But it's difficult for her to attack the shark, because Tyriana's body size does not allow her to dive underwater. T-Rex decides to retreat to even shallower water. Megan the Megalodon drops, trying to bite the dinosaur, and just rams her with all of her 50-ton weight. The T-Rex loses her balance and falls down. Now, nothing can help her. Uh-oh. So, Megalodon proves again that she was the ultimate predator and could easily defeat the world's most famous dinosaur. They ruled the planet for over 170 million years and then disappeared. History says it was a huge city-sized asteroid that came from space and hit the land of the Yucatan Peninsula around 66 million years ago. It caused terrible environmental changes, debris in the air blocking the sunlight so the plants couldn't survive. Temperatures on Earth's surface plunged. The animals were struggling to survive until they finally went extinct. At least, that's something many paleontologists believe happened. Now, they found out dinosaurs were about to go extinct even before the asteroid. Their diversity started to go down 10 million years before the asteroid. Older, long-living species didn't evolve enough to adapt to all changes in the environment, such as higher sea levels, massive volcanic activity, cooler periods. Dinosaurs preferred a warm climate because it helped them to keep a stable body temperature. Dinosaurs lived on all 7 continents, even in Antarctica. That's because it wasn't all ice back then. Around 90 million years ago, Antarctica was a swampy rainforest with a warm, pleasant climate. It was even in a different location, only 560 miles from the then South Pole. That was the time of the warmest climate on our planet. The sea level was 560 feet higher than today, and the tropical sea surface could reach temperatures up to 95 degrees. Antarctica still had something like polar night, months without sunlight, but the climate around the South Pole was mild and temperate, with no ice masses. Dinosaurs didn't shed their skin in one long piece like today's reptiles do. Scientists believe they shed it in small pieces, had something like dinosaur fur. There was a dinosaur, Pagomastax, that looked like a cross between a porcupine and a parrot. It had 1-inch long jaws and ate plants. It had a short beak and self-sharpening long teeth. They were like scissors this small dinosaur used to slice up plants. Our modern lion has a mighty bite, but a big and scary T-Rex bites more than 2 times stronger. The king of the dinosaurs has the strongest bite amongst all land animals, 3.5 times stronger than today's record holder, the Australian saltwater crocodile. It also had the longest teeth, almost 10 inches long, the length of an iPad. Most modern animals are either warm-blooded or cold-blooded. Dinosaurs were somewhere in between. Scientists think they mainly were mesotherms, which means the activity of their muscles could warm their bodies